I want you to get hard on your next cloud architect interview, so I made this video for you. Hi, I'm Mike Gibbs, a chief architect with over 26 years of experience. I've interviewed thousands of architects, and after all these interviews, I can tell you the main reason people fail the architect interview is they answer questions like a cloud engineer. But the problem is, hiring managers judge architects differently than they judge engineers. And the answers that will get a cloud engineer hired will not get an architect hired. So in this video, I'm going to show you how to answer 4 common cloud architect interview questions with the kind of answers that will get you hired. The first question we will ask is, how do you control cloud costs? Here's how I would expect an architect to answer it. Controlling cloud costs really starts with the architectural design, not by waiting until the build becomes a problem. The 2 biggest decisions we make as architects that have the biggest impact on cost are, where do we host the workload and the architectural approach for the workload. For example, a high throughput compute workload may be 1/5 of the cost in the private cloud. Or let's look at a serverless function. For an event-driven and frequently used application, serverless can be a huge cost saver. But that same serverless architecture in a high throughput environment may cost 10 times more than a monolithic architecture working on a virtual machine. So the key is, I don't make any architectural decisions without understanding deeply the business's needs and the technology analysis for that organization. Now that analysis is going to begin with, what workloads are strategic? Which workloads are temporary? What performance levels are actually required? What type of availability does the business need? Which environments are going to be production, non-production, development, or experimental? Now, from there, we really need to understand the usage patterns prior to any cloud migration, as this is going to help us right-size compute instances, understand where maybe serverless or managed service is appropriate, help us pick the right storage tier, and even be able to purchase the right type of compute, often at a much lower cost because we know exactly what we need and we can buy for that. And that's part of it. The other side is actually seeing what's going on, constantly monitoring and tuning. And for that, we're going to set up some monitoring. And the reason we're going to do this is we can't optimize later what we don't understand. Now, how do we do that? Typically in our architecture, we will set up tagging standards. We will set up cost centers. We will make sure that chargeback reporting occurs and there's budgets and alerts. And that way we know what's going on and we're armed with information to fix it later. Now, we also have to set up some governance. And I typically work with engineering and finance and application owners and even business stakeholders to define cost guardrails. And the goal here is to maybe make it that development teams can deploy within an approved pattern. While anything that's going to be really expensive, for example, would require an approval. And that's really how I manage cloud costs. Now, here is where many technical candidates actually destroy the interview. They talk about shutting down unused services. Now, while that's not wrong, that's an engineering answer, not an architect level answer. So the next question, and this is really going to separate the architects from the engineers on this one, is how do you measure the success of a cloud architecture? The way I would answer it is, I measure the success of the cloud architecture by how well it delivers on the actual business outcomes that were the driver of the architecture. And in order to do that, my process is as follows. Prior to starting any architecture project, I first meet with the project's executive sponsors. I ask them their vision of the architecture, determine the scope of the architecture, and how the end business will actually measure success. Now, at this point, I'm going to get the business drivers. I will also understand and obtain the objectives and key results to measure after the fact. For example, if the goal of the architecture was to increase revenue, and the client wanted to design an AI recommendation engine to increase revenue or sales on their e-commerce website, we can measure success easily by looking at the website's revenue before and after the AI recommendation engine. And we can easily measure, Did that recommendation engine increase sales? And if so, by how much? And as long as we measure the architecture by the original business case, we're tracking the right things. I'll give you some other examples. If the goal was to improve resilience, then success would be measured by resilience metrics. If the goal was to reduce cost, then success would be measured in cost efficiency. If the goal was to accelerate innovation, then we would measure it by speed, our reuse of maybe architectural patterns, and business responsiveness to change. In the end, an architecture is successful because it meets the business needs, not because it's technically impressive. The next question is, how do you design disaster recovery in the cloud? Now, the way I would answer it, the kind of answer I'm expecting, is as follows. I start all disaster recovery planning with a business impact analysis. And that helps me understand how much downtime the business can tolerate, how much data loss the business can tolerate, which systems are mission critical and which ones are not. What would an outage cost the business? What regulatory obligations apply to this business? As without knowing the business needs, it's going to be impossible to build an appropriate and cost-effective strategy. Now, once we've done that business impact analysis, I can define the recovery time objective, or RTO, which must be less than the maximum amount of tolerable downtime the business can handle. The next thing I'll define is the recovery plan objective, which must be less than the maximum amount of data loss the business can tolerate. Now, regarding the architectural design, there was realistically 4 approaches we can use based upon the business needs. The first approach to cloud disaster recovery, or option 1, is that we create a backup of system images and data, and we also create an infrastructure as code script. And if an outage were to occur, an engineer will kick off that infrastructure as code script, it will launch the systems, and it will be up and running. Now, the trade-offs here is that it takes some time to get up and running, and it takes manual intervention. But the upside is it's very low cost. Now, the second option we have for cloud disaster recovery environment is to create a backup of all system images and data and create an infrastructure as code script like the last option. But in this option, we keep our databases synchronized in the disaster recovery environment and the primary cloud or data center. And in this matter, and if an outage occurs, what happens is the engineer kicks off the script, launches the systems, and it's up and running. Now, the upside of this is it's fairly low cost. And there's really minimal data loss because our databases are synchronized. At least a lot of key data is maintained. The downside here is it takes manual intervention, and it's still going to take some time to get this up and running. Now, option 3 is where things start to get really dynamic and interesting. What we can do is we can create a second cloud environment. So, for example, if our primary cloud is AWS, we can create a second cloud environment in, say, Google or Azure. And what we will do is we create a small replica of the primary environment. So if we've got 10,000 servers in AWS, maybe the replica is 50 small servers sitting over there in Azure. And we set up these servers with an auto-scaling group. So what happens if the primary cloud were to fail? All traffic will be sent to the backup cloud. Now, the backup cloud doesn't have the capacity to handle it because it's got small instances running, but auto-scaling will take that backup cloud to full capacity in 45 minutes or so. Now, what's great about this option is it's moderately fast. I mean, inside of 45 minutes, everything's at full capacity. And this architecture is also automated. So as soon as an outage is detected, all traffic shifts over to the new cloud. So lots of great things about this, but that also comes with a bit of a higher cost. Now, the last option for disaster recovery environment is to create a second identical environment. So if we have those 10,000 servers on AWS, we've got those same 10,000 servers on Azure. As soon as one of the cloud providers would fail, traffic would be shifted to the other one. Fast, automated, and with literally minimal downtime or data loss. But the trade-off here is this gets very expensive because we're basically building 100% double replica of everything we care. The key to remember with disaster recovery is what we're designing is for the level of protection the organization and the organization businesses needs. Now, where people go wrong is they answer that disaster recovery question like a backup question. And that's a very engineering answer. An architect must answer it like a business survival question, because that's really what disaster recovery is. Now, the next question is often asked is, how do you define a target state cloud architecture? Now, here's how I would answer that as an architect to show the business components of the job. I would say, to make sure that the architecture is going to provide real business value, I'm going to go through a fairly significant process to create that target state architecture. I'm going to start with the executive sponsors of the architecture project. I'm going to learn their goals, the vision for the project, and the scope of the architecture. Now, this will also give me the opportunity in that initial meeting to find the actual business drivers of the architecture. Are we architecting for revenue growth, for example, or cost reduction, or risk reduction, or operational efficiency, or whatever the target actually is that our architectural design is meant to accomplish? The next thing that we will do is I will evaluate the current state of the business architecture, the current data architecture, application architectures, and technology architectures. And while I'm doing that, I'll be speaking with key stakeholders across the organization. And that will give me a lot of information. I'll be able to assess architectural maturity. I'll be able to assess the organization's readiness for change, as well as the capabilities of that organization, plus everything that they have now. And now we're in a pretty good position because we know what they have, we know what their goals are, and where they want to go. So the next thing is me and my architecture team will evaluate all those current architectures that we talked about, like the data architecture, the application architecture, the technology architecture, and the business architecture. And we'll evaluate their ability to support those future business goals and capabilities that they came to us for in the first place. And we're going to evaluate those architectures, and we're going to find gaps in their ability to support the needed business capabilities and the needed business goals they desire. From there, what we're going to do is we're going to work backwards from the capabilities they're trying to achieve to create the future application architecture, data architecture, technology architectures, which form the basis of our target cloud architecture. Now, at that point, we've got an architecture that should be good, but we're going to bring it back to the organization's key stakeholders. We're going to get their feedback and tune it to make sure we support their business needs. And once we've got a final approved architecture, now we need to create the solutions architecture, which is going to be the actual products and services that we'll use. And that's really how we go from a business goal to a target state cloud architecture. If you notice, there's a pattern. Every answer started with the business and then moved to the technology. And that's really going to be the difference between sounding like a cloud architect and sounding like a cloud engineer. Now, if you want to start your architect journey and become a cloud architect or an enterprise architect or a security architect or an AI architect, each week I run 2 completely free webinars on Zoom. We will deep dive on how to become an architect. We will talk about what we do as architects, the skills that you need as an architect, what hiring managers desire in an architect, what certifications you should get, and even how to stand out from the crowd and get that first architect job. You can register for these free architecture webinars by looking in the description of this video. These webinars will be on Zoom, so you can ask me any type of architect career question you have on these free webinars, and I hope to see you there. Now, if you enjoyed this video, please give it a like, subscribe to this YouTube channel, and hit the bell to be notified of new videos to assist you in your architecture career. I hope to see you in another video or a free webinar soon. Take care, everyone.